Say our topic for the day is the transformation of functions, or transformations. And by transformations, I mean we are going to take some basic function and move it about, either up or down, vertical shifts, left or right, horizontal shifts. We'll even combine vertical and horizontal shifts. Another form of transformation is a reflection, say about the x-axis. Another is to stretch or compress a function vertically. So let's start off with vertical shifts, and they have the form g of x equals f of x plus or minus k, where k is greater than 0. So let's grab some fundamental functions such as f of x equals x squared. And we know the graph of this is a parabola whose vertex is at the origin. And a point on the graph of this parabola, when x is 2, square 2, you get 4. Y equals 4. So now our g of x becomes g of x equals f of x, but f of x is x squared. And I'll I'll choose the minus and put a 3 in for k. So now let's graph this. And let's see. G of 0, we'll find the y-intercept. G of 0, replacing x with 0, we just get 0. 0 minus 3 is minus 3. So we can graph this thing. And we'll go down 3 units. 0, 3. And notice, the only coordinate that's changed here is the y-coordinate, because, keep in mind, y equals g of x. Okay, so now the graph looks like this. And let's see, when we evaluated f of x for 2, the corresponding value was 4. So let's evaluate g of 2. And when you square 2, you get 4 minus 3 equals 1. So now when we go over 2, we go up 1, and the y-coordinate corresponding to 2 is 1. Notice, we shifted the graph down 3 units. That means every corresponding point on the graph will get a vertical shift down of 3 units. 4 minus 3 is 1. And that's a vertical shift, and we're done. Now we'll look at a horizontal shift. So we'll choose f of x to once more equal x squared, and we know the graph of that is a parabola whose vertex is at the origin. A point on this parabola is 2, 4, and we also know that we can replace the variable with parentheses, and whatever we install here we must install there. So I'll put an x minus 3 here and a corresponding x minus 3 there. Also, what value of x will take that expression to 0? Well, we'll do a little aside and set x minus 3 equal to 0. So adding 3 to both sides, x equals 3. So we know that if we replace x with 3, we'll get a 0 here. So now let's build g of x. So g of x equals f of the quantity x minus 3, but that is x minus 3 quantity squared. And we know that if we let x equal 3, this thing will go to 0. So we'll evaluate g of 3, and we get 3 minus 3 is 0, which corresponds to the ordered pair 3, 0. Now let's graph this. And we'll go over 3 units. Here we are at 3, 0. Also, we need an x and a y. Also, let's find the y-intercept since we're at it. So we will evaluate g of 0. And what we get is, let's see, 0 minus 3, when we square that, we get a 9. So the y-intercept is at 0, 9. And now, recall when we let x equal 2, we had a 4. So let's see what we get when for g of 2. G of 2 equals, let's see, replacing x with 2, we get 2 minus 3 is negative 1. Square negative 1, we get 1. So when we go over 2, we go up 1, and 2, 1. Okay, and there's a vertical shift. Notice, the vertex was shifted 3 units to the right. Correspondingly, every point on this curve was shifted 3 units to the right. We're done.